First, if you're given a plane equation, well, if you're given a single equation, which is linear, meaning all the powers are 1, you should know that it's a plane equation. First question has to do with, can you read off the normal vector from the equation? So x minus 2y minus 4z equals to negative 5. To read the normal vector, you should first write in the form ax plus by plus cz equal to d. So I wrote it like that. Then you know that 1 comma negative 2 comma negative 4 is the normal vector. Okay. When you have ABC equals to D, the vector A comma B comma C is a three-dimensional vector which is normal to the plane that's given to you. Now you might wonder, what's the role of D then? This number basically tells you how far you're from the origin. It moves you away from the origin. The bigger this number is, or if this number is, absolute value is bigger, it becomes further and further from the origin. Okay. All right, then you have, how do you check that a certain point is on the plane given? How do you know that this is on the plane? Or how do you know that this is not on the plane? How do you check that?
Plug it in.
Plug it in. If the equal sign holds, that means it's on the plane. If the equal sign does not hold, then it's not on the plane. Right? That's what it means, right? So you have negative 3 plugged into x, minus 2, negative 1 plugged into y, plus 5, and 4, and 1 plugged into z. And let's cross our fingers that this equal sign indeed holds. This is negative 3 plus 2 plus 5. So the left side is this, which is equal to 4. That's exactly the right side, right? So it does work. Check. Now let V be a vector from this point to that point, and we're supposed to find the component of n to component of V in the n's direction. How do you do that? Well, you do terminal minus initial, so it's 2, negative 1 minus 1. V is 2, negative 1, negative 1, and then minus negative 3, negative 1, 1. Which is 5, 0, negative 2. That's your V. And then we have to compute the component. Now, there are two types of projections, right? The one that we call component, the other one we call the projection, right? What's the difference? What's the difference between this one and this one, projection?
Forms a right angle.
No.
Component is scalar.
Huh?
One of them scalar, one of them's vector.
Yeah. Which one's the scalar?
Component.
Component is a scalar, and projection is a vector. Okay. The length of the projection, magnitude of the projection vector, is the absolute value of the component. Okay. Component is almost like the magnitude of this, except that it also can have a negative value if the angle between the two vectors is, if these two vectors have an obtuse angle, if it's more than 90 degrees. Okay. So basically, the picture is this. If you have two vectors, A and B, component looks at this length right here. How much of this vector is actually in the B's direction? That's what component does. Projection turns this into a vector. So if you make the vector going that direction, that's called projection. Okay? And the formula is component of u to v is u dot v over v, and projection of u over v is u dot v over v squared. Those are the formulas. Okay, so let's try this. You have this vector 5, 0, negative 2 projected onto the n vector, which is 1, negative 2, negative 4. Negative 2, negative 4. And therefore, using that formula, it's 5, 0, negative 2, dotted with 1, negative 2, negative 4, divided by the length of 1, negative 2, negative 4. Now, the only confusing thing about this formula is, which one do you divide by? Do you divide by u or v? Well, you just divide by whichever is under here. Okay? That's how you remember. And the reasoning is simple. You really want this length to be growing bigger as a increases. Right? If v's length actually don't count. So what happens here is that v's length doesn't count when you're thinking about the projection of u in the v's direction. Only v's direction counts. So dividing by the length of v has to do with getting rid of the length information of v. That's what you're doing. All right, so you have dot product, which is pairwise multiplication, and you have to add. That's what dot product is. 5 times 1 plus 0 times negative 2, negative 2 times negative 4. Magnitude is square root of the squares added together. That's 5 and 8, so that's 13. And the bottom it's 16, it's 21. So that's the component. And then the question was, what's the distance from 2, negative 1, negative 1 to this plane? And the answer to D is this exact thing. And the reason for that is, think about the following picture. You have a plane, and you have a normal vector perpendicular to it. And here is some point that's outside the plane, which we call 2, negative 1, negative 1. And let's say this point is negative 3, negative 1, 1. So you're given these 2 points, one on the plane, another outside the plane. And if you want to know how far this one is to the plane, the plan is to do the following. First, make a vector out of the two things, and then figure out the component. That's the component that we just found out, right? And if you think about it, that's exactly the distance between the point and the plane. Distance from the point to the plane, the shortest distance from the point to the plane is exactly the same as the component. And I think I actually wrote down the formula
So C
for...
and D are the same answer?
So C and D will give you the same answer. Okay? I think I gave you the formula that if you want the distance from, say, x1, y1, z1 to a x minus x naught plus b y minus y naught plus c z minus z naught equal to 0. The way you do it is, first take the difference between this one to this. See, x naught, y naught, z naught is some point on the plane. So taking the difference between the two gives you a vector connecting the 2 points. Okay? And so here's the vector, and you want to know the component of this vector in the direction of the normal vector, which is a, b, c. So that's the formula for finding the distance between a point in the plane, which is calculated by using this afterwards. So that's what this question is about. Yes?
So what would you do with the point 2, comma, negative 1, comma, negative 1?
Oh, I used it here to get the vector.
Oh, okay.